Welcome to Brain Vision.
Here the direction of omega sub 1 is along the axle of the wheel, and this is to the left. So we can then say that this is the negative I hat direction. We can also say that the direction for omega sub 2, this is along the axis of rotation. And which is straight up. So this is straight upwards. And so the direction for omega sub 2, this would be the positive k hat direction. These would be your answers for part A. For part B, they want us to find the magnitude of the angular velocity. This would be the square root of omega sub 1 squared plus omega sub 2 squared. This is simply due to Pythagorean's theorem. And this would be the square root of 44.0 radians per second quantity squared plus 35.0 radians per second quantity squared. And we find that omega, the magnitude of the angular velocity would be 56.2 radians per second. And if we wanted to find the angle between the two, the angle with the angle between the two angular velocities, or the angle with which the magnitude of the angular velocity is directed, we can say theta would be equaling arctan of omega sub 2 divided by omega sub 1. And so this would be arctan of 35.0 divided by 44.0, and this is equaling 38.5 degrees. This would be your direction, and this would be essentially above the negative x-axis. We can then say this would be your magnitude and your direction. And then for part C, they want us to find essentially the vector form for the angular acceleration. And the angular acceleration, by definition, will be equal to the derivative of the angular velocity with respect to time. And we can say that here, because the angular velocity vector is equaling the angular velocity vector sub 1 plus the angular velocity vector sub 2, we can then say that omega sub 2 is going to be constant. We know this. It's a constant 35.0 radians per second k hat. And so we can say that alpha, the angular acceleration, would be essentially equaling the derivative of omega sub 1 divided by, with respect to dt, because the angular velocity sub 2, this doesn't change, therefore there isn't any angular acceleration. We know that here omega sub 1 is rotating counterclockwise about the z-axis. We can say that at t, if the figure is at, when I say figure, I just mean the system, really. If the system is at t equals 0, then we can say that omega sub 1 would be equaling the magnitude of omega sub 1 times negative cosine omega sub 2 times ti hat minus sine of omega sub 2 t j hat. And so we can say alpha then, for part C, alpha would be equaling d omega with respect to d omega over dt. This is equaling d omega sub 1 plus omega sub 2 with respect to dt. And this is equaling d times omega sub 1 dt. And we can then say alpha is equaling d times omega sub 1 times negative cosine omega sub 2 ti hat minus sine of omega sub 2 tj hat. And this would be, of course, again, with respect to time. And this would be omega sub 1 omega sub 2 multiplied by sine omega sub 2 ti hat, and then minus cosine of omega sub 2 tj hat. You're simply taking the derivative of negative cosine and negative sine. And so the angular acceleration at t equals 0 seconds, this would be equaling omega sub 1 omega sub 2 times negative j hat. And so this is equaling negative 44.0 radians per second multiplied by 35.0 radians per second. Again, j hat. We find that the angular acceleration at, we just say again, angular acceleration at t equals 0 seconds. This would be equaling to negative 1,540 radians per second squared, j hat. This would be your answer here. That is the end of the solution.